Hello everyone. The topic for the day is limiting reagent. So let's first understand what is a limiting reagent. Let's take an example first and then learn it via the definition. Let's say we want to make a sandwich. A sandwich requires two pieces of bread and let's say a slice of cheese. And let's say I have 6 pieces of bread and I have 2 slices of cheese. So what we see over here is that I can make only 2 sandwiches even though I have 6 pieces, because what's happening over here is the amount of cheese is not sufficient enough. For example, in the first sandwich, I will use the first 2 breads and a cheese slice. Similarly, in sandwich number 2, the same. However, there is no cheese available for the third sandwich. And hence, cheese over here is our limiting reagent. So, what exactly is a limiting reagent? Let's say sometimes how do I go back? Okay, so sometimes one of the reactant is not present in amounts as required by a balanced chemical reaction. And it is present in excess amount over the other.
मैं जाऊँगा
The reactant present in lesser amount is consumed, and after some time no further reaction takes place. Hence, the reactant which is completely consumed limits the amount of product formed. and this is the limiting reagent. Now let's take an example to really understand what is a limiting reagent. How do you really find a limiting reagent in a particular equation? So let's take an example. So whenever you want to find the limiting reagent, step 1, what we do is we first balance the chemical reaction. Step 2, we calculate number of moles for the reactants and products. Then step 3 is where we divide the number of moles by the stoichiometric coefficient. Now this step is the most important step. Why? The lowest ratio available in step 3 is the limiting reagent. And then what we do next is we proceed according to the limiting reagent to find the number of moles produced. So use the limiting reagent to find the number of moles of product formed or the number of moles of reactant consumed. Okay, so let's take an example. So let's say we have Haber's process. So let's say we write the equation first. So we know that the balanced chemical equation is N2 plus 3H2 gives us 2NH3. And let's say we have around 14 grams of ammonia available, and let's say we have 12 grams of nitrogen available, and we have to calculate the amount of ammonia produced. In grams, volume, and let's say in terms of moles. So that's the question. Now, how do we go ahead with this? Step 1. The reaction is already balanced. Step 2. Calculate the number of moles. So here what we find is if we calculate the number of moles of nitrogen, that would be 14 grams over 28. So we get that as 0.5, and the moles of hydrogen is, we have 12 grams of hydrogen over, and we have molar mass is 2, so that will be 6. Okay. In step 3, what we do is we find the ratio of the mole by stoichiometry ratio, so stoichiometric coefficient. So for nitrogen, that ratio is 0.5 over 1, so that is 0.5, and for hydrogen that comes to 6 over 3, so that is 2. And now looking at step 3, we realize that N2 is our limiting reagent. Why? Because the number of mole to stoichiometry ratio is lower for nitrogen. And now what we do is we simply use nitrogen to decide the amount of ammonia produced. So when I look at the equation, I see here that 1 mole of N2 produces 2 moles of NH3, but what we have in the equation is we have 0.5 moles of N2. So how much will that produce? That will produce 1 mole of ammonia. And if we want to find in terms of grams, in terms of volume, so 1 mole of ammonia is 17 grams and 22.4 liters. So that is how we use limiting reagents. That was a basic example. There are many other different types of questions which can come on the basis of limiting reagent. Thank you so much.